Perfect. All right. So hi, everyone. Thanks so much for joining today. As Russ said, this is the second in a larger lecture series on technical tools for open science. And today I get to introduce you to what I think is one of the most impactful tools that we have, not only for open science, but also for just kind of working more broadly day to day, and that's Git and its interactions with GitHub. So first, kind of to motivate this work, there are many different angles that we could think about when we're talking about Git and GitHub for why it's a useful set of tools. But I want to take a very personal angle first. So I think this is a scenario that many of us might be familiar with. You're writing, let's say, a manuscript, or you're designing a new analysis, and you think you have the final version, and you take it to your collaborator and you show it, and they have a few corrections, let's say. So you go, you make the corrections, you think, all right, this time I'm done. But this is maybe where it sounds familiar. It's not just a few corrections. You'll see that, you get comments back, you make revisions, you get comments back, you make revisions, and now you're getting corrections on the comments, you're getting more corrections, and at the end, you're finally so swarming in changes that you don't have a great way to organize how exactly this version at the end of this collaboration relates to the final version that you really started with, right? And so this is something that I think is a common experience, not only as in this example for writing manuscripts, but really for almost anything we can do in science. And version control is really designed to help us in these situations. Now, you may be thinking to yourself, okay, this sounds feasible, but most of the time, for many of the things I'm working on, I'm really working by myself. So, this isn't something that's going to apply to me if, most of the analyses I write are things that I'm coding up, I'm running, and, I'm the only person looking at, right? And to that, I would say, even when you're working alone, your number one collaborator is always yourself from 6 months ago, and they don't answer emails. So it's a really good idea to have some kind of system in place to try and help with this problem of making changes over time, either in response to your own changes as you integrate more work and gain more time on a particular problem, or changes from collaborators, or both, right? So because this is such a common problem that so many of us have faced, many of us have many different solutions. And so kind of as in the last comic, this may also look somewhat familiar, right? So you have a test and a retest file and a retest. And so you can see how as these file names go through, there's sort of a sense of versioning in them, right? You can sort of imagine like, okay, here's the initial test, and I see that the date is included in the file name, so I can imagine it's moving forward over time. But then, you've got this confusion of here's this one. If you come back to this directory in 6 months, you have this confusion of here's this one that's called use this one, and then a few days later, starting over. So if you don't remember the exact process that went through here, how do you know which one to use? Do you really use the use this one? Do you use the starting over? Is there something you want from one of the files in between? And this can be a huge time sink, trying to reconstruct, what exactly your mental process was when you were creating these files 6 months prior, a year prior, or more, right? And so this makes it really difficult to do reproducible science, and also just to reorient quickly and build on your own work over time. And so what we'd like to do is explore better solutions rather than just file naming to try and address this problem. And so the general class of solutions is version control. And version control is just a series of systems that enable us to track exactly what's changed in a file or a series of files over time. And so the way that I want to present this, there are many different ways we could talk about version control, but the way I want to present it is as a conversation that's unfolding over time between people. And maybe that's just your past self and your present self. Maybe that's between you and your collaborators. But I find that this framework of a conversation is really helpful to motivate why version control is so, so important when we're thinking about how do we structure our workflows in a way that allows for reproducible science. Because when we're thinking about a conversation, it allows us to recognize that, not only are we making these changes for our own benefit, but we're also making them for the benefit of, future collaborators, future scientists who may come along and want to orient to our work or build on it in some way. So the thing about conversations in any, domain-specific field, I know all of us as scientists are familiar with this, is there's always jargon, right? You always have to learn the jargon of this particular field when you're new to it. And Git and GitHub, which is the version control system we're going to be using, is no exception. So here are just a few words that are very commonly used in the Git and GitHub landscape that may seem totally unfamiliar if you haven't worked in this space before. Things like commit, pushing, pulling, forking, cloning. They all have meanings in English that we might be familiar with, but they also have very specific meanings in Git and GitHub. And today I'm going to try and orient you very broadly to their usage. But, as with any kind of language or conversation, what I really want to emphasize is that as you use these more and more over time, they'll become more fluid. In the beginning, what we're really trying to do is just to make you aware of these terms and aware of the jargon in this space so that you can use it and use it fluently. So what we want to avoid when we're doing a conversation is this scenario. So this is a comic from XKCD that says, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy, right? So this is not what we want. I think this is kind of the other danger when you think about things like in the conversation framework. If you only learn a few key phrases in a foreign language, you can easily over-rely on those, right? You can go to restaurants and just know how to say, like, can I have water, or something like that. But what we really want is to move towards fluidity. And the only way that that's going to happen is with practice. So my goal for today is to actually show you some of this in terms of how we do Git and GitHub and what that really looks like. But I just want to emphasize that this is not something where at the end of the hour, I would expect you to be able to say, I'm super confident that I could fully do all of any Git kind of issue you throw at me, I could solve it. I could do anything I want to do in Git or on GitHub. That's not probably going to happen. All we're trying to do today is to orient you to this landscape and to keep this kind of framework in mind as you explore more, knowing that it will become more natural the more you use these tools. And for mistakes, there's always dangitgit.com is one resource, but there's always many, many people online who are very happy to commiserate because we all have made some major Git mistakes and they can be recovered from. So if you're ready to get started, what we're going to do today is I'm going to walk through two pieces of this short course that I've put together. And although there's a lot of material in the course, because this is only an hour lecture, I'm going to focus on two sections, which are tracking changes with a local repository and getting started with GitHub. If you have time and interest, I would strongly encourage you to work through the rest of the material as you're available. It'll cover a lot of really important concepts that I think will make your life much, much easier as you move more in this space and you use these tools more fluidly to do more of your work. But I think for today, we'll kind of focus on just the broad strokes approach. So let's just do that. All right. So this is exactly that link that I just promised you, the Git course. And so what we're going to do is I have my terminal here, which I think you can see, and we're going to navigate to this tracking changes with a local repository. So I've already done some of this stuff at the beginning, which is just for setup, and it just allows you to make sure that when you're working on your own computer, you have everything set up for what you need. So here, for example, if I just show .git config, that's going to show, my name, the email I use for Git, and some other settings that I have in place. So assuming you've done that, assuming you have a system where you have Git installed and you've provided some basic information about yourself, what we're going to do is we're actually going to just make a new repository. Just for now, just a new folder, right? So if you went to the last CORES talk in this talk series, you're probably already familiar with the Unix command line. If you're not, no worries. You can definitely catch up on that recording when it becomes available. Otherwise, I'm just going to use a few commands to allow us to quickly create some resources that we can use. So first, I'm just going to change directories into my home directory, confirming that that's my home directory. And then I'm going to make sure that this directory does not yet exist, which it does not. That's perfect. I had once had someone who it did exist, so I always check now. All right, so we're going to make this directory and we're going to change into it. So this is a new blank directory called Git papers, right? There's nothing here, which is exactly what we want. And what's nice is that because it's empty, we can now use it and initialize a Git repository. And so it's going to tell us, great, there's nothing here, right? If we do ls again, it looks like it's empty. But if we do this ls.git, where the dot indicates a hidden directory, you can see that actually, exactly as suggested here, we have all of these configuration files. That git init created all of this information. And so this is really useful because this is where the actual versioning of all of our work is going to be stored. So what we're going to do now is we're going to create a file, one that contains content that we're interested in. So I'm going to use the editor Nano. I just find it's really easy. But as discussed in the tutorials, you can use almost anything you want on your system. So if I do Nano, I'm going to create this new file called journal.md. And within it, I'm going to say what I want my paper title to be. So my super cool paper by me, right? So I'm going to save that. And then I'm going to use this command called git status. And what that's going to do, I'll make this a little bigger so you can see. What that's going to do is it's going to tell me some information. It's going to tell me the branch that I'm on. It's going to tell me what commits I have made already, what files are currently tracked or untracked. So here it's putting this journal file in red to indicate that it's untracked. And it said nothing added to commit, whoops, but untracked files are present. Use git add to track. So this is one really nice thing about Git that we'll notice as we go along is it tries quite often to be helpful and to guess what it is you want to do. So in fact, it's correct. What we want to do is we want to tell Git to pay attention to this file. So Git by default, even though we've told it, this folder is going to have files that we want you to pay attention to because we've initted a new Git directory here. It's not going to pay attention to a file unless we tell it to. It doesn't want to accidentally include information that we don't want it to include, right? It's very nice. And so what we're going to do is we're going to go ahead and say, okay, do exactly what you suggested, which is to add this file. And now we can just run our git status command again. This command is always super useful. So here we now see we have some of the same information as before. So again, it says the branch we're on, that we don't have any commits yet. And now though it tells us we have new changes that are to be committed. So here it's saying this new file journal.md is going to be committed, right? And so you may notice that we're now tracking this file. We weren't doing that before, but it's giving us this distinction that even though it's tracked, it's not yet committed. So I just want to show you in this little schematic here, show you in this little schematic how we can think about that, right? So if we have a change. In this case, it's the addition of this file. Git add is going to put that change in something that we'll call the staging area. This is like the loading dock where all our changes go. You then do a separate call called git commit, which is going to be used to actually incorporate those changes into our version control record, right? And so that is going to kind of put everything in a package. The nice thing about this is you can add multiple files, you can add multiple parts of a file. Doing it this way allows you to kind of logically group whatever changes you've made into a structure that makes sense to you, and then associate them with a single but interpretable commit. So that sounds great. How do we actually do that, right? So what we're going to do is, now that we've done this git add, we can just call git commit. And then it's going to go ahead and launch whatever editor we've told it to launch. In this case, I told it I really like Nano, so let's use Nano. And it's going to ask us to please enter a commit message for your changes. So Git now knows what we've committed, but it doesn't know why. So let's give it a human interpretable kind of message that we can read back later and see, what was I really trying to do when I made this change? And so we'll say we were trying to add title and authors. Right? Great. Okay, now we're going to go back to our already favorite command, git status. And it's going to say, we're on the same branch, nothing to commit, but now it also says working tree clean, right? So what does that mean? What we're seeing is that there are no files that Git doesn't know what to do with. That means that every file is accounted for, so to speak. So every file that's being tracked hasn't been modified, and there are no untracked files. So Git seems pretty happy. Let's go ahead and keep going. So now let's pull up our journal article again. Still has the changes we made last time. And I'm going to add something else. Let's say I'm going to write an introduction. Very motivating introduction, right, for any scientific work. So if I save this change and we now run git status, we can see that now we're saying we've modified this file. So it is tracking, unlike before where it said untracked, it is tracking this journal file, but it notices that we've made some changes and we haven't yet added or committed those. So what are we going to do? We're going to go ahead and add the file and make a commit. And here, let's just go ahead and pretend we've written a very compelling introduction. All right, so now what we've done is we've made a series of changes. We can go ahead though and move from working on a single file and tracking all the changes there to actually working on a directory, right? So let's go ahead and make a new directory within this Git directory. And let's create a file within that. That I can spell. Awesome. Critical reference for this work. This is not APA formatted, but let's pretend it's a reference, right? So we are going to add a reference in this new file in a subdirectory, and then let's go ahead and modify our journal file. Okay, so we're now citing this non-APA formatted reference. So when we've done that, we can go ahead and do, let's throw in an extra git status here, right? And so now what we can see is, again, we have a tracked file where we have changes that aren't yet added or committed, and we have an untracked directory. So let's go ahead and just add our untracked directory. And now you can see something like this, right? So here what we're seeing is that we have this new file that's ready to be committed, and we've modified our journal file, and we haven't gotten that ready to be committed. So let's go ahead and add a new commit. And here's something fun, right? So you can actually, before what we've been doing is we've just been doing git commit and then entering the message, but git commit has quite a few options actually. One of which is A for all, so it will add all tracked files as well, and M, which is message. So it means we can pass the message on the same line. So I'm gonna say reference citation and add citation file. So if we do a git status, now we go back to seeing what we had before, which is on branch master, nothing to commit, working directory clean. So what's really happening here, right, is that we have this one file that we had before, this journal.md, and we've been adding to it throughout. We had a second file, references, and because we added both of them, we could incorporate them into a single commit, which we use here. And then that commit is going to get stored in our history. And that history is what's going to be really critical for us when we want to review over time to see what we've done, what's changed, you know, how our work has evolved on this project. So overall, taking stock of where we are at the moment, what we've seen just using Git, we can initialize new repositories where we're going to use version control. We're going to use this command git status quite often because it tells us the status of this Git repository. It tells us, you know, what is being modified at any given time, what Git is being told to pay attention to and therefore to record in our version tracking history, and you know where we are in Git if we're on a different branch, which you'll learn about later, or you know if there's any other information. Otherwise, we can use git add to move files that have been modified into a staging area where they can be logically grouped with and then recorded with this git commit. And that when you do git commit, what's really important is that we're going to include this log message. So I showed you how you can include it in one command with this AM, where M is really critical for the message piece. You can also just do git commit, no flags, that'll pop up a new editor, and there you can write a commit message. No matter where you write it, again, this is really the why, right? So Git can take care of all of the logistics for you, but it never really understands the conceptual framework. That's what you need to provide. And that's what's really critical as you move back and review your work to see what's changed. Awesome. Okay. I don't know if there are any questions at this point, but if not, I'm going to go ahead and move on to the next piece, which is moving off of your local computer and getting to GitHub. All right, so this tutorial was promised to be Git and GitHub. And so let's talk a little bit about what GitHub is. So GitHub is a company, and the idea behind the company is it provides remote repositories for Git and some functionality that's really useful to support their use. GitHub isn't the only company or only framework that allows you to have remote repositories for Git. There are other services such as GitLab is popular as well. There's also Bitbucket. All of these allow you to do lots of really useful things like browse code from within a web browser. They allow you to do software release management, issue and bug tracking, project management tools, all kinds of things that are super, super helpful, particularly when you're working with code, as we often are in science, and trying to create analyses, right? And so GitHub obviously isn't the only provider. As I've mentioned, there's GitLab, Bitbucket, among others, but it's really quite popular, and therefore it's really useful to know about. In particular, it has some functionality that many researchers find really useful, such as making your code citable. So it has an integration with Zenodo. It allows you to really easily create DOIs for your analysis code that you can then carry forward and cite in your manuscripts, for example. So this sounds great. You know, we don't yet understand how we're going to link everything we did locally with GitHub, but it sounds nice in theory. If we want to use GitHub, first thing is first, we're going to need an account. So if you already have an account, you can just sign in, as I will. Otherwise, you'll need to sign up. And you can do that just by navigating to github.com. Right. So for me, I already have an account. So this is what my account currently looks like. But what's critical is that once you have this GitHub account, you'll now have a set of credentials that will allow you to add information from your local computer to this remote. And then we'll learn later about how you can take information on GitHub and get it really easily onto your computer with its full version history and everything else. So what we're going to do is on GitHub, we're going to go over here and we're going to click the create icon, which is this little plus now. And we're going to click new repository. So here, what I'm telling you is we're going to call it Git Papers. And if you'll recall, that matches the name we used right here, right? So let's just go ahead and copy this in. Oops, wrong key. Perfect. Okay, so it's going to ask us a few questions. What's critical here is because we're already importing an existing repository, we're not going to click any of these buttons. If you were creating a repository for the first time that you didn't have on your local computer, you might want to look at these. But in this case, we're going to go from local to remote. So let's go ahead and just create it. Great. So again, GitHub, like Git, is trying to be very helpful. It gives us many, many options for what we could do next. But let's go ahead and just do the simplest thing, right? So we already have our local repository. Here it is. We'd like to push it to GitHub. So what are we going to do? We're going to do git at remote add origin. And then I'm going to put in the URL of the repository that I just created. And I'm going to end it with .git. Now, what is this command doing? So we're setting up a remote. And what I mean by that is we're setting up another location that we'd like our code to live. So GitHub as a company provides this storage for us that we can, push this other location. But basically anywhere that's not our current computer is going to be a remote in Git language. So what we're saying is we're going to add a new remote, and we're going to call that remote origin. Again, this is a bit of jargon. You could imagine calling it just about anything. You could call it GitHub. You could call it, my other favorite computer, whatever. But most commonly, this is going to be something that we call origin. And because it's often easier to stick with conventions when we're learning, I'm going to call it origin. All right. So now that I've done this, you can check that it worked by doing git remote v for verbose. And that will tell you that you now have an origin with two locations. We'll get to that in a little, for fetch and push. And in both cases, this is the URL I just created. If you create it, you probably won't have Ian DuPre. You shouldn't. You should have your own GitHub username there. Great. All right, so now what we want to do is we want to push our files, everything we've been working on locally, to GitHub. This is pretty cool because it means we can avoid the nightmare scenario of not having backups of our work. It always makes me nervous. I'm sure it makes other people nervous as well. Git and GitHub, this distributed aspect of our version control system, gives us a really nice way to maintain backups of everything we're doing as we do it. So that's really cool. So let's just do it. So what I can do is I can say git push, again, a bit of jargon. Basically, I'm pushing code from my computer to a remote. U is to set upstream, it's just to set the target. Origin is the name of that thing I told you before, right? And then let's see if it'll let me call it main. Yeah. It wouldn't. That's fine. So the branch name I have right now is slightly older because I don't have my Git configuration updated clearly. But in general, the convention has been changed in the past couple of years to now be main. So I'd encourage you to use that whenever possible, just to explain the discrepancy. Awesome. All right, so it worked. We don't know what it did, but it worked, right? So let's go to that repository we just created. Remember, it looked like this before. And if I refresh, what will I see? Ta-da! I see all the code that I worked on locally. Now, what's really cool is I can also see all those commits that I made. So if I want to go and browse the repository and see exactly what changed with a certain commit, I can do that very, very easily right in the browser. So this is super, super cool, and a huge benefit of working with Git and GitHub together is that now you not only have the version control of Git, but you have the distributed aspect of Git is really being highlighted and shown in our GitHub. All right, that's super cool. So what if we want to go the reverse way, right? I told you that GitHub is pretty amazing because it allows us to take advantage of the distributed nature of Git and have these backups. So what if we pretend something drastic happened? And in this case, when I say something drastic, what I mean is that we, let's say, lose access to this computer, or maybe we just, want to go to a different computer. Nothing bad happened to the computer, right? So what are we going to do? What we're going to do is we're going to leave this directory, make sure that it still exists. Oops. All right, still exists. And now we're going to go ahead and remove Git papers from our local machine, right? Dun, dun, dun. All right, so now we no longer have a local copy of our work. This can be scary. Nothing bad happened in this case, but when you're working on something and maybe you accidentally delete a file you didn't want to delete, it's pretty upsetting. But thanks to Git and GitHub, we have a really quick and easy way to recover those files. So what we're going to do is we're going to use this other bit of jargon called git clone. And we're just going to use the same GitHub address for this repository that I had used before, right? So github.com, my username, gitpapers.git. It's going to tell me that it's cloning into Git papers, has all of this information for me. But what's really cool is I now have an exact copy of everything that was on GitHub, again, including all the version control information. And we can see that if we just change back into that directory, and now I run git log, you can see exactly what I showed you on GitHub before, where you could see the history of the commits. You can see those locally as well. That's pretty cool. We can even see that all of our Git configuration files that I had promised you in the beginning are also conserved. And so this is really nice because it means that, even when we change computers, or if we are accidentally deleting something, we can not only recover exactly what we've done, we can also recover the full version control history so that in 6 months, we have both the copy of the changes and the reason that all of those changes were made. So that's pretty cool. All right, so now we're going to do one more thing with the remote that I think is really useful to know. And this is to show how we can, having cloned a copy of the repository, now turn around and push changes from this clone back to the remote. So you can continue this kind of iterative process between your local machine and any remote, not just on GitHub, but in this case on GitHub. And it doesn't, it can continue infinitely, which is really nice. So we're going to go ahead and run our favorite command. Second favorite command. First is git status. Second favorite command is we're going to actually change a file, right? So we're going to use this journal.md again. And let's add a results section. Something really compelling. All right. So if we run git status again, just to see what we've done, as before, you can see that we've modified this file. So it is being tracked, but Git knows there's a change that we haven't added or committed yet. So if we git add journal.md, and then let's say we git commit, again, it's going to prompt me for a commit message because I didn't pass the M. It's going to open up my editor for me. So I'm going to go ahead and explain what I did. Initial results section. Okay. So git status just to see. Perfect, nothing to commit, working tree clean. So let's do git push origin. Again, that's the name of our remote. Master in this case, because my config is a little bit older. And it's going to tell me that it pushed everything up. So now if we navigate over to GitHub, what we can see is that we have an extra commit, and that extra commit corresponds to exactly what I did locally, right? So this is a really nice kind of framework in which we can iterate between our local and our remote copy and track changes across both of them. So just to kind of highlight the changes from here that I want to emphasize. So Git is our local system. GitHub is the remote repositories provider. Git clone is going to allow us to make a local copy of a remote repository. And then we can git push to push changes from our local repository to the remote repository. Sorry, Russ, I see you added, or you raised your hand.
Yeah, a question that people often have is, how often should I commit my changes, push to my remote? And obviously there's no like right answer to that, but I wanted to see what your advice would be for people about like how often to, to do those things.
No, absolutely. I think it's a really important question, right? And so this is kind of, today I'm really focusing on this broad question of what are these tools and what is kind of the bare bones interaction between them. But when you go to use them in practice, these are exactly the questions that come up. It's how am I really going to integrate this with my workflow? And so in my opinion, I think that commits should really be structured as logical changes. So, if you're working on something and you're like, I want to, I want to work on the paper today. I want to work on a manuscript today. That's a big series of changes, right? You want to do something kind of finer grain, like I'm going to work on this section and then I'm going to work on this section. Or if you're working on analysis code, like I'm going to add this new feature or I'm going to test this particular parameter. That's a nice granularity at which to do changes. But if you're ever concerned in terms of erring on one side or the other, I would always say commit too much rather than too little, because it's easier to go through later and change your history. And, you know, we're not going to talk about this today. It's a bit advanced, but it's easier to group things together later than it is to split them up. So if you have to err, which we all do, I would say err on the side of committing quite often. And then, you know, later, if you see that you want to rearrange things and group them differently, that's something you can do. In terms of how often to push, I consider myself, when it comes to this sort of stuff, reasonably anxious. I like to have copies elsewhere. So I like to push somewhat frequently as I make changes. I would certainly push every day if I'm working on a particular project. That's certainly not required. It really depends on you, but I find that pushing more often, again, gives you a really nice way to kind of track where things are and to really see that progress over time. So the short answer to your question, I would say commit pretty often and push to a remote repository maybe slightly less often, not necessarily every commit, but certainly every few.
Great, thanks.
Awesome. Are there any other questions? I'm having some trouble finding the chat. So hopefully.
I don't see anything in the Q&A.
Awesome. Awesome. Okay. If there are any questions, please don't hesitate to jump in and let us know. All right. We have 15 minutes left, which means we can do something I wasn't sure if we'd have time to do, but I think is really kind of critical. So it's nice to be able to do it. And that's this, right? So I've so far told you about the kind of mechanics for making changes, logging them with Git into a version control system, integrating those changes with some remote repositories provider, in this case, GitHub, and then going back and forth between the two. So cloning from GitHub to get a new copy of a repository, pushing back up, right? And this is, you know, a pretty common workflow, let's say, just when you're working by yourself day to day. But the other nice thing, even when you're working by yourself, is to really take advantage of the history that version control provides, right? So you can see what changed over time. So what we can do in this case is let's go ahead and make one more change to our journal file, right? So let's do nano journal.md. And what I'm going to do is I'm going to add a second reference. All right, so let's pretend that this is, again, a critical reference for our work. If we save this change, we can now do git diff journal.md. And what we can see right away is that Git is going to tell us not only that the file was changed, but this little plus tells us that this line in particular was added. And if we delete a line, it will do exactly the same thing, except it will have a minus instead of a plus in front of it. So this is super, super useful because it allows us to see, you know, if we've been working for a little bit and we want to quickly remember what we've changed over the past, I don't know, let's say hour maybe of working, we can quickly do so with a simple git diff, and it will highlight all of our changes for us in a really readable way. So that's super nice. The other command here that's really nice is this thing I showed you briefly before called git log. So if we explore this a little bit more, rather than just looking at it super quickly, you'll notice there are a couple of things here, right? We've got the word commit this incredibly long string. Then we also have some other information like an author, a date, and a commit message, right? And so what this is doing, or what this signifies, is that behind the scenes, Git is assigning this unique identifier, this very long string, to every change that we make. And it's also recording some really useful information about the change. So it's telling us who the author of the change was, which is really useful, particularly if you're working with several people. You really like to know who wrote the conclusion section, right, of a manuscript. It tells us when the change was made. And then again, just like hammering home how important these commit messages are, it tells us why we said this change was important, or what we said this change was designed to do. So what's nice about this is we can actually view the difference between some commits, not just our most current one, but between almost any commits by using the commit ID. So if we do git diff, let's choose this older commit. You don't need to do the whole thing, by the way. You can do the first few characters, but just because it's easier to copy paste the whole thing. Now it's telling me between that commit and my current version, these were all the lines that we added. So that's a useful thing. We can also do git diff and compare two different older commits. So let's compare this one with this one, right? And now we can see we removed, in Git's mind, we removed this line, which just ended here, and we added this line, which ended after site critical reference. So this is another nice thing to know, is when you're tracking files with Git and GitHub, it's relying on the fact that you're working with plain text files, right? So if you want to be doing something like Microsoft Word or PowerPoint or any kind of binary file, it's not going to work as well because it's really looking at these line by line differences. And so here, because we have an addition on one line, the site critical reference here was added on the same line, it thinks this previous line was removed and this line was added. So it's not going to be able to parse differences within a line. Again, one of the reasons it doesn't work super well with long binary files. And it does work really well with plain text because now we can see exactly what the change was. If you're writing like paragraphs rather than code, which kind of naturally breaks this up, putting every sentence on a new line is a nice way to make sure that it's highlighting changes you want rather than just a small change in a large paragraph. Cool. So that's another nice thing we can do just from the history, right? One more thing that we can do if we have a minute, which it looks like we do, is we can actually go and check out a previous commit. And what that means is, so if I actually, let me, rather than scrolling up endlessly, let me just do git log again. All right, so now you can see, and now I'll do git checkout. Let's say this previous commit, right? So it's trying to help me because it's saying that you have changes that would be overwritten. So let's go ahead and check what our changes are. We can see that we wanted to add this second reference. So let's go ahead and see if we've added it. We haven't. Let's add it and then let's commit it. And this time I'll use that M to pass the commit message directly here. And I'll say add second reference. Great. So now if I go back and do that previous thing where I was checking out this older commit, we'll get a long message. What it's telling us is we are now switching to this previous commit. So the state of our repository is exactly as it was when we made this commit. And you can see that by looking at journal MD itself, right? So it looks as though all of those changes we made, including that change we just made of adding that second reference, aren't there. But don't worry, we didn't actually lose them. If we go ahead and just check out our branch, now let's do the same thing. ls, look at the journal file. Now we can see that we have our results back and we have our second reference back. So we can explore the repository at different points in time, but Git isn't losing any of the information. It's retaining it all for us. And it's allowing us to not only access previous bits of information, but directly compare between different states of the repository at different times when we commit it. And so it's a really nice way to keep up to date or keep in mind everything that you changed over time and kind of what the thought process was as you moved through a particular analysis workflow or writing a particular manuscript. So this is, again, I think a really critical thing, even in this bare bones kind of configuration of making changes for yourself locally, pushing those changes to a remote repository provider like GitHub, interfacing with the history makes it so that you can really take advantage of the version control aspects of Git and see everything that you've done over time and why. All right, so just to summarize, the key points from this would be that there are three really useful commands. Git log is going to show you the commit history for any repository you're working in. That's a Git repository. Git diff is going to show you the differences between commits. So either between what you've done currently and the previous state of a repository, or you can pass previous commits and look at differences between two different commits, and will allow you to see exactly what's changed. Noting again that what's really happening here is it's looking for plain text changes. And so if you're working with long blocks of text, splitting those up between lines is really helpful. And binary files aren't going to be very amenable to this kind of history tracking. And then finally, this Git checkout, which I showed you briefly to explore kind of a snapshot of the previous history or state of the repository, allows you to recover old versions of files and explore what the code looked like at a certain point in time. But even when you explore, even when you roll back, you're not losing any of the changes since then. Git is retaining kind of the complete history. It's just allowing you to access whatever bits of it you think are relevant at a particular time. Okay, so I think that is probably all we have time to cover today. But again, if you're interested in this, as you start to explore it, there are lots and lots of bits and pieces that I think are really useful. So definitely encourage you to check this out. Other resources available, and I'm also happy to take questions now or later as it's useful.
So if you have a question, you can go ahead and put it in the Q&A. I'll just make a couple of comments. I thought this was really great. The next thing on the list there is branching. And I think that, one of the, just, kind of looking forward, if you're, someone who knows a little bit about Git, one of the really cool things about Git is that it lets you try things out. And, we've often had the experience, right, where we have a piece of our code that's working, and we want to add something to it or try something else, and then it doesn't work, and we finally give up, and we want to go back to the previous version. If you're not using version control, that's really challenging, but Git makes it really easy to do that. And then if you give up, you just give up on the branch and leave it there. If you make it work, then you can fold that branch back into your working code, and it's a super useful way for kind of low cost exploration.
Yes. Yeah. And then combining different, and especially, as you collaborate with other folks, combining different ideas. Like there's a really cute graphic in one of these tutorials of if you have an octopus and one person wants to add sunglasses to the drawing and the other wants to add a hat, they do it on different branches. When you come back together, you've got the full outfit, right? So you can add bits and pieces and bring them all together, exactly as you're saying, to kind of explore the space.
One other thing I'll mention, another useful use case that I have, and I think some of the people on the list here might be people who take advantage of, like high performance computing systems like our Sherlock cluster. And often it's, you often want to like do your software development on your local machine, but then, push the code back over to the cluster. And using Git and GitHub makes it really easy to sort of, coordinate code across a couple of very different machines where, instead of having to copy things and like not know what was copied and, what needs to be copied and what changed, Git and GitHub will easily kind of, help you coordinate code across a couple of systems. So I think that's a useful use case that some people here might want to look into.
No, absolutely. Absolutely. And we didn't have time today to do the full kind of workflow. But again, I think even just like the clone and the push, that is really critical to be able to do that from different machines. And then, as you start integrating these more closely, exactly like you're saying, if you want to work across 2 machines and GitHub, then there are other commands like git pull, which will allow you to pull in changes from a given remote rather than just pushing them up. So that's something else definitely to check out and think about how to integrate into your workflow.
Cool. All right. Well, looks like we're at time. So thanks very much, Elizabeth. This is a really great overview. And thank you all for joining us. And hopefully we'll see you next week.
Yes. Thank you so much.
All right. Bye, everybody.